Hello and welcome to problem number 2 for Static Strength Materials Spring 2019. This is for group number 5 and we have been assigned problem 4.5 for our second problem. Now problem 4.5 looks at calculating roof load and transmitting this down to the interior and exterior columns. The first step to calculating the roof load is going to be looking at the snow load. So in order to calculate the snow load on the roof, we have a given snow load of 20 pounds per square foot. So in order to apply this to the roof, we need to take the joists, which are spaced 16 inches on center, and convert this pounds per square foot measurement into a pounds per linear foot along the joists. So in order to do this, we multiply by 16 inches and we divide that by the 12 inches, which is 1.33 feet. We multiply this by the 20 pounds per square foot and get 26.7 pounds per linear foot of snow load. In addition to the snow load, we also have the dead load on the joists. So in order to calculate this, we take the pounds per square foot weights, which are 5 pounds per square foot for the shakes, 2 for the plywood, and 5 for the insulation, and also apply this to the tributary area over each individual joist. So again, we take the 5, the 2, and the 5, and we multiply this by the 1.33 feet, which is the 16 inches on center, and then we add the 4 pounds per linear foot for the dead load of the joist itself. Now doing this, we get 20 pounds per linear foot for the dead load of this material. Now, this material is at an angle, and we've been given the angle on the roof down here at 9 by 12 by 15. So in order to get an accurate dead load, we must take the 20 pounds per linear foot and adjust it for the slope of the roof. So we've taken 20 pounds per linear foot, multiplied it by the 15 over 12, which is the slope of the roof, and we've gotten the adjusted dead load of the roof joists at 25 pounds per linear foot. So those two added together are going to be 51.6 pounds per linear foot per joist. Now that we have the linear pounds per foot of the joists, we can take that and apply it to the ridge beam. So the ridge beam is only going to take half the weight of each side of the joist. So if we take that 17 foot of joist and we divide it by 2, that's going to be half the joist that's applied to the ridge beam. The other half of that joist is going to be applied to the walls. We have 51.6 pounds per linear foot for the weight of the joist times the 17 feet of joist, divided that by 2. So we get a weight of 438 pounds per joist along the ridge beam. So the ridge beam now has a joist on either side, spaced 16 inches on center. So we've taken the 438 pounds the joist is applying on the ridge beam, and we've adjusted that for the 12 over 16 spacing and multiplied that by 2 because of joists on either side of the ridge beam. This comes out to a 657.9 pound per linear foot applied on the ridge beam. Now this number includes the dead weight of the joist, the snow load of the joist, so the live load, but not the pounds per foot of the ridge beam. So in order to get the full weight applied to the ridge beam and of the ridge beam itself, we will now add the 40 pounds per linear foot for the weight of the ridge beam. This comes out to 697 pounds per foot. So below is the free body diagram for the ridge beam's weight over column A and column B. In order to apply this weight to both of these columns, we need to apply this over the tributary area of columns A and columns B. So we'll start with column A. Column A has a tributary area of 11.33 feet. This is half the distance between column A and column B. So we've taken this 22.66, the total distance, divided it by 2, so 11.33, and multiplied it by the 697.9 pounds per linear foot weight of the ridge beam. This comes up with a weight of 7,907.2 pounds applied from the weight of the ridge beam on column A. Now again, this includes the weight of the beam, the joists, and the live load on top of the joists. If we do the same for column B, we end up with the 11.33 and the 11.33 on either side of column B. This is the tributary area that's being applied to column B. If we take this, multiply it by 697.9 pounds per linear foot, we end up with a weight applied to column B of 15,000 pounds, 814.4. So that's how you calculate joist, live, and dead load, apply it to the ridge beam of the column, and come up with the forces that are then applied to the columns supporting the ridge beam.